The following message has been brought to you by the Mile High Flood District. Old infrastructure projects often have an interesting story to tell about the environmental protections in place at the time. Environmental protections have evolved dramatically over the past 50 years, and the visual contrast between older projects and newer projects can be quite striking, particularly along linear infrastructure like highways and waterways. Highways and waterways share common characteristics. They're both long, linear infrastructure that often traverse diverse and sensitive topographic features. Historically, the design approaches for both highways and waterways prioritized speed and efficiency, emphasizing the rapid movement of either cars or water above all else. This approach often neglected environmental and community values, resulting in projects that disrupted natural landscapes and ecosystems. We're going to use a couple of Colorado infrastructure projects to illustrate the design evolution that's occurred over the past 50 years. The highway we'll highlight is I-70 in the mountains west of Denver, and the waterway we'll look at is Little Dry Creek in Westminster. Now, as you travel into the mountains along I-70 west of Denver, you pass through several major infrastructure projects. Loveland Pass serves as a stark example of pre-environmental protection highway design. It was constructed before the National Environmental Policy Act, or NEPA, was signed into law in 1970. We mention NEPA because environmental regulation, although challenging to navigate at times, has definitely spurred more thoughtful and multi-objective design approaches. But the Loveland Pass project was pre-NEPA, so it prioritized vehicle speed and efficiency above all else. A wide road cross-section was imposed upon the existing topography with little regard for the surrounding landscape. The result is a visually abrupt scar that exists to this day, a testament to the single-minded focus on moving cars from point A to point B as quickly as possible at the expense of everything else. The design team was comprised primarily of engineers, making values beyond basic engineering goals less likely to be considered. Similarly, early urban waterways before environmental protections like the Clean Water Act were treated more like concrete ditches than like natural ecosystems. Older flood mitigation projects along Little Dry Creek mirrored the conveyance-centric approach seen on I-70 at Loveland Pass. These early projects, master-planned and designed in the late 1970s and early 1980s, predate the significant influence of the Clean Water Act, which was passed in 1977 but didn't have fully developed design guidance until many years later. The primary goal of these early projects was to move floodwater efficiently from point A to point B, typically by lining streambeds with concrete. Concrete is highly effective at moving water, but when used to this extent, it becomes detrimental to the natural ecosystem. Although concrete lining like this is very hydraulically efficient, when it someday needs to be replaced, it will be quite expensive. Unfortunately, land development adjacent to the creek encroached upon the narrow stream corridor, leaving little room to do much else beyond move floodwater through as fast as possible. So environmental protections such as NEPA and the Clean Water Act marked quite a turning point in highway and waterway design, and later projects show the visual impact. Heading back to I-70, let's move a little further west to Vail Pass, which was constructed in the late 1970s after NEPA was passed. The design was much more environmentally sensitive than the design approach at Loveland Pass. The process included environmental impact assessments and public input processes, ensuring that community values and environmental concerns were valued alongside engineering goals. The design minimized cut and fill slopes, utilizing retaining walls to reduce the highway's footprint, and it included viaducts to facilitate wildlife passage beneath the roadway, protecting both wildlife and motorists. A trail was constructed in the generous space between the east and westbound lanes. It's become a haven for cyclists. Vail Pass is a great example of the power of multi-objective outcomes, and it was delivered by a more diverse design team, including landscape architects, wildlife biologists, archaeologists, and restoration ecologists, highlighting the growing recognition of the need for more diverse perspectives. Section 404 of the Clean Water Act began to exert a more pronounced influence on urban stream design in the 1990s, as the Army Corps of Engineers and the EPA started emphasizing mitigation measures. This initially involved incorporating upland buffers adjacent to streams and restoring impacted wetlands, but the focus gradually expanded to include stream restoration. The shift began with a move away from fully concrete-lined channels to designs like grouted boulder edging like this section of Little Dry Creek. Eventually, the Corps began advocating for even more natural solutions, leading to the adoption of buried soil riprap, often seeded and planted with willow stakes, which provided both bank stabilization and greater ecological function. Although the engineering community was skeptical about the long-term durability of these design approaches, progress was being made. As we head back to I-70, let's continue west to Glenwood Canyon. This stretch of highway was finished in 1992, and multi-objective considerations expanded even further, with the result being one of the most beautiful stretches of highway in the world. They were so meticulous about minimizing the visual impact, they actually stained any exposed rock that was cut so it could blend in with the surrounding landscape. They committed to integrating the highway into the environment rather than just imposing it on the landscape. They took the concept of a highway and considered, how can we make this work in harmony with nature? And the result is something that's not only functional but also visually stunning. The project includes a riverside trail corridor throughout, and the river is used extensively for whitewater rafting and fishing. And this shift toward a more holistic approach to design wasn't just happening along highways. A similar transformation was taking place in the world of urban stream design. The Little Dry Creek at Westminster Station project was a culmination of this evolution, demonstrating the successful integration of flood and stormwater management goals with environmental and community values. This project achieves a level of sophistication comparable to the Glenwood Canyon project. A key feature of the Little Dry Creek project is the extensive use of vegetation, not merely for aesthetic purposes, but as a primary structural element for stream bank stabilization. A diverse palette of grasses, shrubs, and trees was planted, providing both ecological and structural benefits while reducing the reliance on costly and visually intrusive hardened structures. Community connectivity was threaded throughout the project, including beautiful overlooks from the new train station, a center-span bridge crossing the stream, stepping stones to allow people to get down near the water, a new lake for fish and bird habitat, and space was even set aside for a new natural playground. All these features were planned and designed to work together from the outset, involving not only a multidisciplinary design team, but also a diverse group of owners, including multiple local governments and regional transportation agencies. The Little Dry Creek project design philosophy embraced the inherent character of natural systems, community values, multidisciplinary teams, and multi-agency collaboration. The project allows the stream to behave as naturally as possible within the constraints of stormwater management objectives, while also creating an abundance of community and ecological value. The result is a more robust and productive system of infrastructure, rather than limiting functionality to only the channeling away of floodwater as quickly as possible, and it's fully capable of withstanding major floods. So what does the future hold for linear infrastructure design? What's next? Well, we've gone from highways that scar the landscape to these beautiful scenic drives, and from concrete-lined ditches to these thriving riparian ecosystems that are community treasures. A whole new level of what's possible. But what does the future hold? Well, when we think of highways being even more environmentally sensitive, we can't help but think of flying cars like in the movie Back to the Future. If cars were to fly, well then we wouldn't really need roads at all, would we? There would be no environmental impact to mitigate, at least not on the land. Which made us ponder the analogy to urban waterways. The equivalent to flying cars would be promoting so much infiltration with both existing and new land development that runoff could truly mimic pre-development hydrology. What if we got so good at infiltrating runoff that we didn't even need stream restoration or flood mitigation projects to begin with. Well, in that future, we're not just fixing damage that's been done, but actually preventing it in the first place. Healthy highway and waterway corridors that don't need our constant intervention. That is a really powerful vision, almost like going back to the future, but for infrastructure design.